So, good morning. So we're going to talk about how to write an abstract. My name is Cynthia Reinhart-King. I'm a professor at Vanderbilt University, and I've invited Jenna Moiser, who's a PhD student in my lab, to help me out. And so basically, I'm going to present some slides, basically from my perspective as a faculty member, on what I think it takes to write a good abstract. And then Jenna will talk a little bit about, from her perspective as a student, what's been successful for her. The first thing I'll say is, just in introducing myself and my own experience. So like I said, I'm a faculty member at Vanderbilt. I've been going to BMES now for 22 years, I think. My lab currently submits about 10 abstracts a year. And so we do quite a bit of this. But what I'm going to talk about today is how to write an abstract, presumably for BMES, but also a little bit on what you could do in terms of writing an abstract, even for a paper or for a different conference, just what the ingredients to writing a good abstract are. Okay. So the first thing I wanted to say about it is that writing an abstract is really a technical skill, not an art. And this is really an important thing to think about. So it's not really a creative exercise. Actually, scientific writing in general is not a creative exercise. It's really just about filling out a formula. And as engineers, we can appreciate what a formula looks like. So as you think about writing an abstract, don't think about it as the time to pull out your thesaurus and come up with creative flowery words, or even to vary your language very much. It's really just about filling in the points that you need to complete an abstract. Okay, there we go. So the goals of an abstract. So the first goal of an abstract is to just convince a reader that they want to know more. It is to reveal the story. It's not to reveal every detail of the story. You don't have the space. It's usually, a paragraph to a page. And so really the goal of an abstract is to give the reader a sense of what you'd like to convey to them, and to convince them that they either want to hear all of your talk or see your poster or read your paper. The goal of the abstract beyond that really comes in three components. The first is to explain what the problem is in the context of the problem and what others have done or showed. So really just to lay the groundwork and say, so this is the context of the problem. This is what's been done previously. This is where the field is. The next part is really to say, okay, so now what did I do in the context of that problem? So you lay out the problem, you say what's been done previously, and then you identify the gap. And then you say, this is what I did. So usually that's a material and method type comment. So I did to this type of experiment. And then what did you show? So what were your major results? And then what does it mean? So usually one sentence at the end that puts it into a broader context. And I think, as we go along, we'll talk a little bit about what this means, but in terms of putting it into a broader context, it's really about not saying sort of overarching things like this could help cure cancer, or this is going to help people recover from heart attacks. Those are important things, of course, but I think the most powerful conclusion statements are much more specific about what exactly your data is going to do with pushing the field forward. Okay, so types of abstracts. The first thing about writing an abstract is to read the instructions for what the paper or the conference or whatever it is that you're presenting to read the instructions so that you know what they're asking for, right? So that you're going to fulfill the requirements that they want. And the reason is because there are many different types of abstracts. The first is a journal paper. And so this is 250 to 300 words summarizing the findings in your paper. So really, it's just pretty short, to the point, again, very formulaic, but it's just a paragraph. In the context of BMES, the conference abstract It can also be short, but for BMES, they want a page. So this is a page-long abstract broken up into sections. So we'll talk about that. And then there's also longer conference abstracts. So some of you might also be associated with various IEEE subdivisions, and those can be up to 4 pages. So they're mini papers, really, that they also call abstracts. And so, so really, when you're writing your abstract, it's absolutely critical that you read the instructions. The instructions are going to tell you about spacing and formatting and word limits and organization. And you absolutely want to follow that. The last thing you want to do, for instance, is take a conference as an example that's asking for a 1-page abstract and then submit a paragraph because it looks like you're unprepared. It looks like that you don't really understand the conference or what they're asking for. And it also doesn't look like you've done much because everybody else is writing a page and all you have is a paragraph. So you really want to make sure that you're looking at what the conference expects. Okay. So let's talk more about a BMES abstract and specifically what BMES is looking for in their 1-page format. So again, the first thing you want to do is go to their website and look at the requirements. They also have a template there on the different formats and the structures, so you can pull it right off the website so that you know that you're in line with their expectations. The first 2 things are somewhat obvious: a title and an author list. But we're going to talk more about that because it's actually incredibly important. Your title is going to be what ends up in the program. So you want to make sure you spend a decent amount of time thinking about what your title is. Your author list and affiliations. So you want to make sure you're comprehensive. You want to make sure you spell everybody's name right and you write it just as they want it. Which is really important. What you call them day to day might not be how they publish scientifically. You know, just as an example, my full name is Cynthia Reinhart-King. That's how I publish, or that's what I'm called. People to when they speak with me, they call me Cindy or Dr. Reinhart-King. But when I publish, I write Cynthia A. Reinhart-King. And that's how every single one of my publications shows up. And that's how I become PubMed searchable. And that's how people recognize me. And so it's important to be respectful of that. Talk to your co-authors and make sure you're getting their name written as they would like it. And then the meat of the abstract. So you've got an introduction, you've got a materials and methods section, you've got a results and discussion, and then you've got a conclusion. And then references are optional. So typically for an abstract, for like a journal, for instance, it usually isn't referenced. But for BMES, because it's longer, because it's a page, it usually includes a few references. And it's not a lot. It could be as few as 2, 3. I wouldn't go more than 5, just because it takes up space and you really want to use that space to talk about your science. All right, so let's talk about title. What should the title of your abstract be? Again, it's really important because this is the thing that will get directly transposed from your abstract into the program as either a poster or a talk or whatever it is. And you want it to accurately reflect what you're talking about, but you also want to be specific enough that you're drawing the right audience. So the first is make it interesting. So you want it to be specific enough that your audience is going to say, hey, I want to go hear more about that. Give away the punchline. This was something that my postdoc advisor used to say to all of us, which is, I think the tendency for a lot of people to tell a story is a lot like one tells a mystery novel, right? Where you sort of lead up to it and then there's a big reveal at the end, and that you wouldn't give away the story in the title. And that's not really true for science. So science isn't really about a big reveal or a big secret. You really want to tell people right at the outset what you're going to tell them. You want to tell them what you're going to tell them, and then you want to tell them it. And so you really want your title to express your results. No holding back. Whatever your most impactful takeaway message is, that's what you want your title to be. Be specific and precise, but keep it short. So just, again, it's going to go into a program, so you want it to be able to fit in the space that they give you. I think there's probably a word limit or a character limit for BMES, but you definitely want to follow that so that it fits in the space allotted. This is a big one, avoiding unnecessary words. So again, in terms of making it interesting, if you think back to your English class in high school or grade school, they encourage action words, right? They encourage things that are going to draw people in. By saying that, they're really trying to say, use words that count, use words that tell your audience things that really are going to get to the heart of the message that you're trying to convey. And so for your title, you want to avoid unnecessary words, particularly these opening words. So some examples of these things are a study of. So a study of X versus Y, a study of the effects of radiation on cellular response. I mean, right, it couldn't be more vague, right? I mentioned radiation, so, I'm going to talk about radiation, but besides that, you don't really know what the cell response is. You don't know what the effect is. It's incredibly broad. If you read these examples, it also gives you the sense that I don't have results, right? So things like observations of is basically telling you I went to lab, I did a bunch of things, and I'm just going to sort of spew it all out now, as opposed to telling you a story. So you really want to, you want to be comprehensive. You want to be very specific in identifying your title. Again, an example of a report on sounds like something out of a company, right? Like I did a survey consulting report and I'm just going to tell you everything I showed, as opposed to my specific result. And again, I would suggest one of the things that you'll hear me say, and you should be hearing, presuming your advisor say, or the community say, is you really want to read other abstracts to get a sense. So all of the prior BMES program books are online. So you can go in and you can look at prior titles people have chosen. You can even look in your research area. So, if you work in cardiovascular engineering, you can go into the cardiovascular engineering track and look at the prior titles that people have used. I won't promise you that they're all great, or that they're bad. You have to be a little bit discerning, but you can look and see, what really works. What are the titles that make me say, okay, I understand what that study is about and I want to hear more about it. So definitely take a look. Making sure it's unique. So the question is, well, how do I make sure it's unique? Or why do I care if it's unique? Well, first, you want it to be unique because you want people to say, oh, I'm going to learn something I haven't learned before, right? I'm going to hear about something new. How do I figure out if it's unique? The best way to do it is go into PubMed and put it in quotation marks. And so you could literally take the title you're thinking of, put it in quotes, put it in PubMed, hit enter, and see if anything else pops up, and then tweak from there, so that you make sure that yours is unique. This is particularly important if you're writing an abstract for a paper, right? Because once your paper's published, it'll all be in PubMed, and then you'll be up against these other papers, and you want yours to look unique compared to the other papers that have been published. Okay, and then concepts that appear in your abstract should appear in your title. So you don't want to introduce something in your title that doesn't appear in the rest of the abstract, and vice versa. The title has to accurately reflect what your abstract is about. And that might be stating the obvious, but you'd be surprised when you maybe you start off by writing a title and then you write your abstract and then you don't go back to check to make sure that the two things are self-consistent. But it's not even just concepts, it's even words. So I'll go back to one of my original pieces of advice. Scientific abstracts aren't really a time to get unique with language choice. You shouldn't be thinking about, oh, I already used that word, I don't want to use it again. Actually, in science, it's incredibly repetitive, and it's okay to be repetitive. It helps people follow your story. And so the concepts and even words that appear in your abstract can appear in your title. Okay, so let's talk about each individual section. So the first is the introduction, and addressing what is already known, and what gap does your work fill. So this is really where you're going to use references if you're going to use them. If you're writing a BMES abstract, your introduction is probably maybe just the top 20% or so of the page, 20 to 25 at most. You really want to save room for your results. And so you want to be able to say succinctly what's already known, and what gap does your work fill. And then I write know your audience. And this was actually a piece of advice I didn't get until I was already a faculty member, and it was actually given to me by another faculty member, and I think it's really good advice, which is remember where your abstract is going. So for example, if you work in bone tissue engineering and you're writing an abstract all about bone and you're going to go into the orthopedic biomechanics panel at BMES, you don't need to start your abstract by talking about how bone comprises the cytoskeleton and is made up of osteoblasts and osteoclasts and things like this. Right. So presumably everybody in that audience knows what bone is, they know why it's important, and they know what it's made out of. And so you only get a page. Don't use that page laying down a foundation that's so fundamental that your audience doesn't even need to hear it. In my own group, we do a lot of cancer work, and I often tell my students that if we're putting an abstract together and it's headed to a cancer-based journal, we don't want the first line to be metastasis is the leading cause of 90%, or causes 90% of cancer-related deaths. It's the most common statistic people cite with cancer. It's an important one for sure, but anybody who works in cancer who's reading this abstract already knows that. So jump in a little bit faster. You don't need so much runway. So again, know your audience and say, okay, well, who's going to be reading my abstract? If it's going to, again, as orthopedic biomechanics as an example, clearly they know all about orthopedics, they all know about bone. So instead, I'm going to jump right in and I'm going to say, okay, well, my study is specifically about osteoblasts. And so then I can jump in with my first word being osteoblasts are known to blankety blank, and this is what's not known about them, right? So I'm going to jump right into what people do know and what people don't know without providing the 200 years of bone research that comes before it. So know your audience. I will say though, if you're going to a broader study section, somewhere where you're not sure, so an exam, or not study section, I'm just serving on a study section now. If you're going to a broader track, so something like systems biology, right? So if you're headed to the systems biology track where they see research from a million different areas and you want them to focus now on yours, again, cardiovascular cancer or whatever it is, then you can throw in a sentence that helps them hone in a little bit faster. Okay, so that's the introduction. The next section that comes after the introduction is the materials and methods. And in my opinion, this is the easiest section to write. This is literally just what you did. And so you don't have much space, so you have to be a little bit discriminating on what you choose to include in there. You really just want to include the most novel and important methods that you used. The things that you want to leave out for the purposes of an abstract are overly detailed information. It doesn't need to, so if you're writing a materials and methods section for a paper, it has to be detailed enough that someone can reproduce your experiments exactly. That's the criteria for a materials and methods section for a paper, is that somebody has to be able to go in the lab and redo it. For a materials and methods section for an abstract, that is not what you need. You need basically an overview of the methods you work. So you're not going to include concentrations and volumes. There's no need to include routine methods. Routine cell culture, you know, if you're culturing 3T3 fibroblasts, which thousands of people have cultured, you don't need to include all the details about that. Standard cell molecular biology protocols, you know, microscopy or immunostaining or you know, Western blotting, you don't need to include all of the details for that. Routine animal husbandry things, routine chemistries, anything where you can expect that an intelligent scientific audience is familiar with the method. You don't want to use your space to describe that. So what do you include then? So you focus on aspects that are unique to your system. So if you're doing something that, let's say you're doing cell culture, but you had to tweak it. So something about your cell culture is a little bit different, that you needed to add a certain reagent, or maybe you're putting them in hypoxic conditions, or keeping them a slightly higher or lower temperature than is normal. Then those are the things that you want to mention because it's unique to your system. Like that, like I connected to that, any deviations from what's more conventionally done. So if for some reason you're using a protocol that just doesn't work in your system the way it normally would, and you've had to tweak it for some reason, then those sort of deviations are good to include. State-of-the-art newer techniques. So if you're doing something that's been very rarely done, or that your lab invented, or maybe that you invented, then those are the things that you want to include in the abstract. But otherwise, you can use really broad sweeping strokes to describe what you did. You're not going to go into sort of point by point, step by step instructions like you might in a paper. It's really going to be something like, so we'll use the Western blotting example. So you're looking at the expression of a protein. You could say protein expression was tested using Western blotting after treatment of cells with streptozotocin, whatever your favorite chemical is. So really 30,000 foot view kind of stuff, not I used this antibody for 30 minutes and things like this. Those level of details you just don't have space to include. So that's the materials and methods section. Results. So this is the most important part of the entire abstract. So basically it is what it sounds like. It's your results. What did you find? For BMES, you absolutely should be including a figure, preferably a multi-part figure. This is probably the most important thing. One of the tricks of anything that you do, whether it's apply for an award or put in an abstract or put in a paper, is try and put on the hat for a second of the reviewer. So when reviews are done for BMES, there's panels of faculty who are basically reading through abstracts, trying to decide what to give a talk, what to give a poster, what to get rejected. And really the criteria for BMES for being rejected is if you simply don't have data, then you likely will not be accepted. But beyond that, if you have a figure and it's well presented, they're really just deciding between a poster and a presentation, which are both great things to do, but that's basically the decision that they're making. But the reason to include a figure is so that they, first of all, it looks nice. It's just pleasing to the eye, but it also draws the reader there pretty much immediately. So the person can go right to it and say, okay, so this is what we're talking about. This is the data this person's going to tell me about. And honestly, they may even skip reading the nitty gritty of your abstract if that figure is really good and self-explanatory, and they'll say, okay, I can see the story. It's going to be a good talk. So your figure is really where you want to invest a decent amount of time, really choosing what part of your data you want to include. Make the figure look publication quality. So this is really important. I've heard many people say this, but the message is, if you want your paper to go to Science, you should make it look like the figures belong in Science. Now that's a high bar, but it tells you the way to think about it, which is if you want your paper to be highlighted, you want your paper to be accepted or reviewed, you want it to make it look like it belongs where it's going. And this is good advice for abstracts, but it's also good advice for posters, and it's good advice for submitting papers for publication, which is make your figures look like they belong, that they were put together well, and that they're aesthetically pleasing. And it is certainly possible to take really awesome data and present it in such a way that is lost by just not graphing it well or depicting it well. And so you want to take the time to make your data look good. So what do you think about when you think about these things? Using readable font, this is really big. Don't use the Excel default settings. So you guys all know, right? You can go in Excel, have it graph something, it's going to spit something out, and then you're going to cut and paste that into your abstract. And the default settings are not the prettiest settings necessarily, right? And they might not be the best settings for what you're trying to depict. So tweak them. Make sure that the font is uniform with the rest of the font that you're using in your text. Make sure that it's the right size for the figure that you're using, making sure that for instance, in a bar graph, that all the titles to the bar graph are readable, that the color matches maybe the scheme for the rest of it. So if you have pictures of cells or something, you're going to choose a bar graph that looks good with that. Even if it's just black, that's fine. But the default blue that Excel often uses, it just also shows a lack of caring when you use the default. You just threw it together. And so you really want to make sure that you tweak it so that it looks as good as it can be. Including scale bars. So if you're going to include, say, microscopy images, you want to make sure scale bars are there. Statistical significant markers, clear legends, again, clear axis titles. If the reader can't read them, then they're not going to really appreciate them. So you want to make sure that you take the time to do that. And then the other aspect of results is reporting the results in a logical way to tell the story the way you want the reader to take the way you want the reader to take away the story from your talk. So what I mean by that is the tendency, I think, for a lot of people is to present a research story in the way that you did it, right? So first I showed this, and then because I found this, I did this, and because I found this, I thought it'd be interesting to do this. And that's okay. That's a fine way to do it. And that might actually work well for your story. But I would encourage you to take your figures and take your data and say, but is it the most impactful way to present my data? You don't necessarily have to tell the reader the story in the same way that you did it. You want to tell it in a way that makes the most sense and that is the most impactful. So that could mean leaving some data out that led you down the wrong path. It could mean flipping the story. It could mean starting off with the most interesting piece of data, the thing that really like tied it all together, and then telling all of the stuff that contributed to it, right? So I'm going to tell you the big finding, and then I'm going to tell you all the pieces that contributed, as opposed to telling you all the small pieces and then telling you the big reveal at the end, right? So oftentimes when we're writing papers, I have my students lay out all the figures and then we jumble them together like a puzzle and decide what's the best way to present them. And I would say you could do the same thing for an abstract, because your results section is basically this mini story of because this wasn't known in the field, this is what I did. And then because I showed this, this is what I did. And right, so you're going to walk the reader through a story, and it's your choice as to how you want to tell that story. It doesn't have to be in the order that it happened to you. It just has to be in a way that makes sense and is logical for the reader. Be sure to cite the figure in your discussion of the results. So sort of rookie mistake, if you're going to include a figure, you absolutely have to talk about it specifically in the results section. So you have to refer to it. So you have to say, our data indicate X increases with Y, parentheses, figure 1. It often flows better when you do it that way, when you state the result and then just put the figure in parentheses, as opposed to saying, in figure 1, we show blah, 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 blah. So that's sort of implied when you put it in parentheses at the end. But by walking it through that way, the flow and the story aren't as good. So if you were to present your results section by saying, in figure 1, we show this, and figure 2, we show this, and figure 3, show this, it really doesn't have the same sort of flow as saying, since prior data had indicated this, we showed this, parentheses, figure 1. And because of that, we then ran this experiment that showed this, parentheses, figure 2, right? So in the first example, I'm really just laundry listing my results. In the second example, I'm telling you a story about my results and how they unfolded. And so I'd encourage you not to just to not discuss your figure in your figure, if that makes sense. So put it in parentheses, but don't make it the subject of your sentence. All right, so I included this graph as an example this is actually right out of the BMES abstract, and wanted to discuss with you guys what made this a good graph or what made this bad. No offense to BMES. So there are a few things that make it great. So first, it's very clear, right? I can see pretty much immediately what it's going to show. It's very well labeled, so I know what each bar represents. I know what the x-axis is. I know what the y-axis is. The graph has a title, so even if I haven't read the text of the abstract, I can see what the data is going to be on the graph. There are things that I would change if I were doing this myself. So again, back to that default Excel setting. These lines, are they really necessary? Are they adding to the story? The spacing is quite large here. Is that really necessary? The size of the font, so it really depends on how big the figure is when I paste it back into my document. But I would say because it's not bolded and because it's a little bit smaller, it might be a little bit hard to read once it goes back into my abstract, depending on how big it is. It's reporting number of attendees as a graph, but it doesn't have any error bars. So maybe attendees by day or something like this. So it is probably missing a little bit of information in there. Generally, you want to have some sort of form of plus or minus error on your graphs. So I'm getting a little bit nitpicky, but we are talking about a professional abstract. So you want to look at those things pretty carefully. And again, I would say if you were going to spend time on anything, your abstract, your figures, and your results are really it. That's where you want to invest the bulk of your time, really explaining what your results are. Okay, and then the last section is the conclusion section. The most important part of the conclusion sentence, well, let me say what it is. It's just 1 to 2 sentences that gives the takeaway message of your whole abstract, right? So let's say I didn't do anything else except to read your conclusion sentence and your title. Between those two pieces of information, I have a pretty good sense of what you're showing. So your conclusion sentence shouldn't simply be, this work will help develop better therapeutic treatments for myocardial infarction, right? Like that's way too broad and probably describes like 50% of the abstracts to the cardiovascular engineering track. So you really want to make sure that the sentence that you use gives the reader a much more firm grasp of what you did specifically. What do your results show? And then you can include some interpretation there. So, what does it mean in the broader context? But really, you want that take-home message really clear. Do not introduce new information here. This is a summary statement. So you could provide a little bit of interpretation of your results if you like, but you shouldn't be introducing an entirely new conclusion that your results haven't alluded to all the way through the paper, right? So you don't want to suddenly throw in a word you haven't used somewhere above. Every word in your conclusion sentence presumably has shown up somewhere in your abstract. Don't overstate or overinterpret your findings. This is a really fatal flaw that even I continue to make, and certainly my students make. You really, it's okay to speculate, but you want to say that if you're speculating. You don't want to indicate that your results showed something that you didn't show. You have to be really critical, self-critical about that to make sure that the results that you're reporting are reflected in the data that you've shown, and that you aren't trying to say something that you didn't actually show. Okay, so that's so those are the key elements of an abstract. Again, this was tailored very much to BMES because we're leading up to the BMES meeting, and it's really, I think, the abstract format for BMES is a little bit unique, but every conference has a unique format, but these elements are always the same. So the format's going to change, but the elements are going to be always going to be the same. And the things that will change are the length of these different sections, whether or not they are sections or whether or not it's just one paragraph or one page of just continuous text. So really, again, to underscore it in a lot, you want to go back and make sure that you're really reading the instructions. Okay, so what about shorter abstracts? So again, so this was BMES, but what about other things? Because presumably your data is so great that you're putting into BMES that you're going to want to try and publish it, and you need it into another format. And so for a journal. So if you're applying and submitting your work to a journal, how do you write your abstract? So the first thing I'll say about this is that for my own students, I typically tell them it's best to write your results section first and then your abstract. You really want your abstract to reflect what you're discussing. You don't want to introduce new concepts in your abstract that you don't put elsewhere in the paper. Sometimes we leave the abstracts until the very end so that, again, it really reflects what's in the paper. So what about formatting? So for a journal, they typically don't include subsections. So if you go into PubMed and you look at the abstracts of papers, they're usually just a paragraph, not into little subsections. There's some exceptions. So there's a few clinical journals that do ask you for an intro, a results, and a conclusion. And in those cases, they're each like one sentence, maybe two, but that's very journal specific. So as you're writing your abstract, go into the journal instruction for authors and look to see what those formats look like. And then look at the journal, look at what how people have structured their abstracts previously, so that you can do something similar. They include all the same info that we've been discussing, it's just condensed. So you basically write a couple of sentences of what's already known, a sentence that describes the gap in the field, the question you're answering, a sentence on the methods, and then 2 to 4 sentences on the major findings, and a sentence stating the conclusion. So this is a formula, no need to deviate from it. So, I know there's a real desire to be creative or unique, or say, oh, I'm going to do things a little bit differently. But when people are reading an abstract, this is the flow that they expect. They expect you to tell them, what's the gap? What did you do? What did you find? And what's your major conclusion? It's just the formula that we all need to follow. And if you read abstracts, well-written abstracts, you can go back and you could highlight each one of these sections and it should look just like this 100% of the time. Telling them what isn't known, telling them what you did, telling them what you found and how you filled that gap. It's always the formula. So again, it's a formula, not a creative exercise. So if you find yourself struggling to write an abstract, and even if you don't, I encourage you to read other abstracts because it has a flow. It has a very formulaic flow that after you read a few of them, you can just churn out your thoughts into the same format. Again, it's not a creative exercise. Okay, other style tips. Following instructions on formatting, font, margins, line spacing. This is really important. So there's certain conferences that say 1 page, and if you submit a page and a line, it's going to get rejected. You won't be able to upload it, or it will just get rejected at review. I think BMES, you can't upload it, at least in prior years. So you need to make sure that when you convert it to PDF or when you upload it onto the site or whatever you're doing, it follows all of these criteria. This is a really important rule in general. You guys are undergraduates. A lot of you might be considering applying to, for instance, the NSF-GRFP. Once you get into graduate school, you might apply for an F-31. Even if you're heading out into industry, there's going to be reporting guidelines that you need to follow. For grants, if you don't follow their rules on margins, line spacing, fonts, things like this, you could have spent months writing your fellowship application. And if you submit it breaking the formatting rules, they won't review it. They'll send it back without review. And they don't give you a chance to re-upload it. They'll say, sorry. So I've had students who have had applications rejected from various funding agencies for formatting. So those instructions are really, really important. I can't overemphasize how important it is to read the instructions on font, margins, and line spacing. And don't expect your advisor to fix those things. Those things that, like, at least for me as an advisor, I assume that my students are reading those author instructions, that they're getting them right, and that I'm really looking for scientific content, not for that sort of stuff. It's really, I think, on the first author to make sure that's done correctly. Remember who your audience is. So again, if you only get a page or you only get a paragraph, don't spend that space retelling the history of your field. Assume that the person going in already knows that, and that you're just going to be basically catching them up to what the latest state of the art is and what the gap in that state of the art is. So remember who you're talking to. And that's a good message in science in general, right? Which is when you're talking to somebody, trying to gauge pretty fast what they know, so that you can decide how deep you can go into your story without losing them. So remembering who your audience is. Avoid flowery language. So again, this is not the time to pull out your thesaurus and come up with some creative word or something like this. You really just want to be pretty straightforward in reporting your results. There's no reason to try and flounce them up with language. Proofread, then proofread again. For better or worse, things like spelling mistakes and typos convey a level of sloppiness to a reviewer. And even if it's not intentionally, it could be subconscious where they just look at it and they say, well, they didn't care a lot, so I'm not going to care a lot. And again, it might not be a conscious thought, but when typos show up, it sends the reviewer the wrong message. So you want to make sure that you don't have grammar issues. If you're not a native English speaker, it's definitely time to reach out for help and just have someone read it over and make sure that there are no grammar mistakes and things like that with it, which most people are happy to do, and just making sure it's nice and solid. And honestly, even if you're a fantastic writer, it's still a really good idea to have other people read it over to make sure that you didn't miss something. I know that silly things. I have found typos on my CV where autocorrect kicked in and made. Literally, I had a typo on my CV for a while that took the word work and made it the word walk, which are both correct words, but very different meanings. And certainly I was not doing a lot of volunteering walking. I was working. So important to get right. Concluding thoughts, at least on my end, abstract writing is a technical skill. So even if you went in, as a lot of us engineers, and said, oh, well, I wasn't so great in English in high school and college, I avoided those courses, and I'm not going to be such a great scientific writer. That is not true. It's really a skill, not an art. And the way to get good at abstract writing or paper writing is actually the same way you get good at everyday writing too, which is reading a lot. And so I tell my students a lot that I can tell if they're reading the literature, because if they hand me an abstract that doesn't follow that formula, it tells me they're not reading. Because if you read enough, it just becomes part of your language. It becomes part of the way you talk about your results. It gets ingrained in you. And so really the best way to get good at it is to read abstracts, read other papers, read many examples. Practice makes perfect. So the more you write, the better off you are. I understand part of this day is going to be coming up with various exercises to help you guys write abstracts, which I just think is fantastic. It's actually a terrific exercise to read someone else's paper without an abstract and then just think, well, how would I write this abstract? What would be the way I write that first sentence that says what's known and what the gap is? What would be the 2 or 3 sentences that I would use to discuss my results? It can take some time, but it's a good mental exercise to just say, well, how would I do it? The other thing I would say about that too is, at least for me, I know that there are certain labs that are really good at writing, and they're often the people I tell my students to make sure they read their papers. And not necessarily for science, they can certainly read them for the science too, but also just for the formula, to read it because they're really good at following that formula. I had a graduate student in my lab once who we were at BMES, and I saw him listening to a talk that had nothing to do with our research. And I said, well, why did you go to that talk? And he said, well, because they're really good at putting figures together. They're really good at depicting their data. And I just wanted to see how they were doing it. So he didn't go to hear the science. He went to go to see how the science was presented. And I will tell you, he was one of the best students I've had in terms of putting stories together and putting really good figures together. And it's because he treated it like a technical practice itself, something he needed to learn and learn from others. So something to keep in mind. Okay, so that's all I was going to cover. I'm going to now toss it over to Jenna, who's going to give you a few slides on the student perspective and tips that she has.
Yeah, so like she said, my name is Jenna Moiser, and I am going into my 4th year of grad school at Vanderbilt University, and I'll be going over some tips on formulating the abstract from the student perspective. So when you set out to write an abstract, one of the first things that you should look at is, like we talked about, that posted guideline for wherever you're submitting. BMES has one specifically, but generally anywhere you submit an abstract will have some sort of template or guideline. And an abstract for a conference is usually different from a paper abstract. So as Dr. Reinhart-King mentioned, there's usually different sections with their own header or title in a BMES abstract, and you can include a figure. So it's essential to make sure that you're going online, looking at these guidelines and templates, and then following the instructions. So sometimes if the formatting is incorrect, like we talked about, they won't even read the abstract. So you really want to download this template, and then because BMES has a Word document with all the different headings and things that you need, you can go ahead and download it and fill it in as you get started. That way it's already in the like proper formatting and you know that you have all the correct settings. So again, just making sure you're paying attention to those formatting guidelines. And then once you have a working draft of your abstract, you should utilize your resources to get it into the best shape that it can be. So these resources include working with your advisor, as they are experts in the field, going to student writing centers that are typically available on campus, and then looking at published examples, as these are really going to set you up for creating something that's already been accepted and you know the right format and structure. So we can go through each one of these. The first one, working with your advisor. This is critical to achieving the best abstract possible. You should send your copy to your advisor at least once to review, giving them plenty of time to look this over. You can't send them a draft an hour before the deadline and expect them to give it their most careful review. They just won't have the time. And additionally, you don't really want to send your first draft. You want to read it a couple times, get input from your peers and maybe your lab mates, and make sure there's no minor like grammar or formatting mistakes, since again, that's not what you really want your advisor or the person you're working for to be editing. These people have likely submitted dozens, if not hundreds of abstracts in their lifetime, and they have very, very valuable advice. So you really want to maximize that input. And these are experts in your field, like I said. They've done this plenty of times before. They know science, they know your science, so they're very familiar with what will be important to bring out in the abstracts. And they also have experience with writing in general, so they're going to know that structure and formula that's going to make it a successful abstract. So you really want them to be editing the content and not things like grammar or formatting. So sending them that polished version and giving yourself enough time to incorporate these edits is really critical. You should also consider utilizing the student writing centers that are available through your university. So these are on almost all campuses, and they're really useful tools that are designed to help students just like you in submitting essays, abstracts, and even applications. So they will go through grad school applications or scholarship applications. And they are dedicated to this specific process of going through the writing. And if these are available to you, you might as well use them. So one important thing to keep in mind is, like we talked about, abstract writing is not creative. There's a very structured way to approach it. And again, there are people in these centers that are dedicated to understanding that formula, so they can really help you setting up this abstract. Additionally, they can help you with basic questions like grammar and spelling that are necessary for a good abstract. So if this is one of the first places you go, just to make sure that your formatting looks okay and your word choice is okay, these are super useful. Lastly, you want to make sure you're utilizing the BMES archive, which is posted online. So these are all the abstracts that have been submitted and accepted at BMES, and they are posted publicly for you to read. And these are super useful in looking at the structure and format and how you're going to fill the page. So things like, where should my figure be, or how big should my figure be, or how detailed should I go in my methods. So this is a good metric for determining how to fill that one page that you're given so that it's both aesthetically pleasing and encompassing the necessary detail that you need. So again, this is posted on their website. You can just log in and look at that annual meeting abstract archive and look at abstracts from years in the past, just again to look at what is successful. So when you get down to the nitty-gritty of your abstract, such as your author list, you want to think about this ahead of time. It's super important to make sure you know which authors you're including and what kind of information you need. So you don't want to have your whole abstract written and then get online to submit the day of and realize you don't know the email address or the university address for one of your authors. So it requires more than just their name. And you want to make sure you're requesting that information or just looking it up on your own ahead of time, both so that you're not like rushing when you go to submit and you don't have to worry about getting a response from somebody like really close to that deadline. So when you're submitting, the system usually requests the university affiliation and again, often the address, and then also the contact information for each author. So you want to make sure that you're getting their preferred email or whatever like contact information that they're asking for. And you want to look at this again, just a few days or the day of the deadline to make sure you have everything you need. When you're submitting, you also want to make sure you're double and triple checking your spelling and titles. So one of the things about this BMES abstract is you can't change anything once you submit. So you want to check it beforehand. You would hate to have someone's name misspelled that contributed to your project and helped you out along the way. Also, you or one of your authors may be on some sort of funding source or grant that requires acknowledgements in submitted work. So making sure that you're acknowledging any of those funding sources in that dedicated section within the abstract is super important if that is a requirement. So when you're submitting to a conference, maybe for the first time, you want to make sure that you're playing to your strengths. And by that, I mean, emphasize the data that you've already collected and use your whole page to tell the story. So a figure is a super compelling component in your abstract, as that's where people tend to look first. It's this pretty figure, it draws the eye. So put your most exciting results there and on display. And additionally, the data you submit should be mostly complete. You don't want to plan a bunch of work before the actual conference date and then hit some unexpected roadblock or issue with your science and then not have enough for your presentation. So you want it to be complete, you want to emphasize what you have, and then you also want to use references to really aid in that background information. And this is going to emphasize the motivation for your work and give a little bit of information about the hypothesis of your work. And in deciding how to convince the reader of that hypothesis, it's important to create your story. So as Dr. Reinhart-King went over, it's important to ask the big questions in your abstract and then get more specific along the way as you go. So you want to start with the big question, and that is, what's already known in my field? So this is going to be, like we said, those first few sentences in the intro. So what is the context for this specific research? What background does my reader need to know in order to understand where this project is going to go? You then want to think about what's unknown in the field. So what motivated this specific hypothesis? What is the gap in knowledge? So you've talked about what's already out there, what you're looking to find. And then you finally want to state your hypothesis directly and think about how and why you're going to answer this question. So as you think about your story, organizing it from this most broad understanding to the specific way you're going to investigate is going to give a nice flow to your reader so that they can start to think about the impact of this work. So when you get into that how, you're thinking about the methods you're using. And then when you think about the why are we interested, it's really about that impact and the motivation for that work. So when you're going into thinking about why your work matters, so in addition to creating this convincing story, you also want to include the impact on the field as a whole. So how is this filling that gap in knowledge and why is it important? And this means that you're not just stating your biggest findings, but you're also including like why they matter and what their impact will be on the field and how they're going to change the way that people look at your area of research. You also really want to focus on where this will go in that concluding statement. So what do these results mean for the future of the project or the future of the field? Are you using this to develop some sort of platform to look at something or identifying key targets in some sort of disease or treatment? So thinking about why your research matters is going to make your abstract more successful and more impactful to present at a talk or something. So you really want to convince your reader that you should be presenting this work at BMES or whatever conference you're going to. And finally, this has been mentioned before, but it really can't be stressed enough. You want to give yourself enough time to submit. So inevitably, when you go to submit, things will come up. There may be Wi-Fi issues or system issues if there are too many people on at once, things like that. So if you can, try not to wait until that very last minute so that you have adequate time to check things like the formatting or the font size or loading up that PDF into the system so that it can check all of this for you. And you really want to make sure that you have enough time to make necessary changes so you're not, again, going right up against that deadline. So to wrap up and review, remember you're given a template online specifically for BMES, but most conferences have this as well. So utilize that template. Like I said, you can download it and fill it in as you go, or just make sure you have all those proper headings and font size and that sort of thing. You also want to make sure you're working with your advisor and your peers, as again, they're experts in the field and also in your project specifically. So they've seen you work on this. And so they can give valuable feedback on the content of your abstract and what you should be, how you should be organizing it. Also, you really want to be respectful of their time. These are very busy people. They're probably submitting abstracts of their own. So you want to give them enough time to read through it and not waste their time on things like spelling or font size. And then finally, make sure you're trying to tell the most compelling story that the reviewer wants to see on your presentation or poster. So thinking about the impact, those motivating questions, and really emphasizing why your research in particular should be shared. So taking all those things together and saying, why does this matter and where is it going to go? So with that, I want to say thank you everybody for joining us on this nice Saturday morning, and we're happy to take any questions.
Excellent. Well, thank you, Jenna, and thank you, Dr. Cynthia Reinhart-King, for coming today and talking about abstract submissions. We really appreciate it. To all our attendees, we're going to be spending 30 minutes doing breakout room work on your abstract submissions for the competition. So I've just posted those links. Go ahead and join a room and get some individual attention on your abstracts. And then we'll reconvene later. Thank you so much, everyone.